Okay, in our next video, we're going to look at writing equivalent radical expressions. We are going to use our perfect square factors. So let's list off our perfect squares. If you square all of your whole numbers, those are the numbers we want. I will say that 1 is a perfect square, but it does not help us reduce a radical at all. So I'm going to start with 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and we could continue this list for as long as we need it. So if we find that we don't have one big enough, then we are going to continue this list, but that'll be our start. Okay, so we are going to answer this question. What is an equivalent expression for the square root of 63? So we want to try to find a perfect square factor that fits into 63. And to save ourselves some work, let's always focus on finding the biggest perfect square factor. So does 4 fit into 63? No, it's not a factor. Is 9 a factor of 63? It is, 7 times. So square root of 63 is equivalent to the square root of 9 times 7, which we know using that property, we can break apart like that. Now, I am very intentional in the way that I write this, and I want you guys to do the same thing. When you are rewriting with factors, the perfect square factor that you found, always put that on the left side. Then when we rewrite and break up that square root into the square root of 9 times the square root of 7, we are going to be able to take the square root of the one on the left side, and that will just carry down. The square root of 9 is 3, and the square root of 7 comes down. I see a lot of students make mistakes if they put these in the other order. It's a weird thing that doesn't seem like a big deal, but trust me, always put the perfect square on the left side, and you are setting yourself up for success in getting the final answer. All right, square root of 144. Not 144, square root of 44. So let's look at our perfect squares. Do any of these perfect squares, are they a factor of 44? Well, 4 is a factor with 11. 4 times 11 is 44, and none of the others will fit in. So square root of 44 is 4 times 11. So now we can break apart our square root, and then we know that the square root of 4 is 2, and the square root of 11 comes down, and we have written an equivalent expression. This is what we call reduced radical form. And again, notice that I put the perfect square on the left side. When I'm writing my factors, it always goes first, always on the left. All right, part B, what looks different about this? Do you guys notice that there's a 3 in front? So what I like to do is circle the 3 so I don't forget it. I might even right now just put a little arrow so I remember that that has to come down. But square root of 27, do any of our perfect squares fit into 27? 9 does 3 times, so we have a perfect square factor of 9 times 3, and then that is square root of 9 times the square root of 3, and then the square root of 9 we know is 3. Square root of 3 comes down, and then this is catching my eye. Remember, we got to do something here. This 3 that was out front gets multiplied by the square root of 27. Well, square root of 27 we just reduced down to 3 root 3, so that 3 comes down and multiplies with anything that ended up out in front of your radical. So we're going to multiply those 3's together and get 9 times the square root of 3.